All right, so we are live. So welcome to the, well, at least for me, it's the first one of 2019 TST meeting. And thanks, Andrea, for running the meeting last time regarding the application list. So today, the primary topic is a presentation from Adib, who's from Purdue University. He's going to tell us about a system for distributing the events via gRPC and how it's being used for various applications that are off platform. I think this is going to dovetail really nicely with some of the topics that we're discussing for our next generation ONOS. So this is great. I'm really happy to have you do this. And also, the secondary topic will be to bring some closure to the application list. So we'll do that in the second part of the presentation. But first, without further ado, let me give the floor to Adib. Please take it away.
Hello, everyone. Do you hear me well, right?
Yes.
Okay. Thanks, Thomas, for the introduction. So I'm Adib Rastigarnia, a PhD candidate of computer science from Purdue University. Today, I'm going to present a gRPC-based event distribution application in ONOS that we can use for externalization of the event processing. So in this presentation, first, I will have a quick introduction about the current weaknesses of the STM controllers in general. And then I will move on to talk about the steps that have been taken so far for disaggregating the control plane and as a potential solution that we can use to address some of those weaknesses. Then I will present an event distribution system based on gRPC in ONOS, and we will see that how can we use this application in order to migrate from a monolithic architecture to a microservice architecture. So I will talk about the technical details of the app, and I also prepared 2 demos to give you an idea about the usage of the app in practice. As all of you know, current STM controllers have been designed based on a monolithic architecture. It means that all of the control plane subsystems, all of the applications and services have been integrated into a single program. So it means that if programmers want to develop their management application, they have been restricted to a specific programming language. They have been restricted to a set of predefined programming interfaces that they need to use for developing of their applications. Even if we use northbound interfaces like REST API to develop external applications, so at this moment, there is no mechanism to provide packaging messages to the external application, and we can just use northbound interfaces to develop proactive-based applications. So in this project, we are trying to address some of these problems. If you remember from the previous Open Networking Summit in Amsterdam, David Benbridge presented a tool called Floaty to externalize packet processing. And so OpenFloaty is a proxy that sits between an OpenFlow controller and OpenFlow device, and the main functionality is to pass the incoming packets from the network devices to the external processes. So David Benbridge also described the concept of the control plane disaggregation, and OFT, OpenFloaty, is a proof of concept towards the control plane disaggregation. The problem is that it only supports packeting events, and it's just a proof of concept. So at that time, we were looking for a tool like OpenFloaty to use in our project, Umbrella project, which has been designed to provide a unified software-defined network programming framework for developing of the applications independent of the STM controllers. It means that we should be able to write one single application and execute it on different STM controllers. The problem was that in Umbrella project, it was originally designed for proactive-based applications. So we used OpenFloaty in our project to support reactive-based application as well. So Then we decided to move forward and see that how can we generalize the idea of externalization of packet processing to something more general, a mechanism that can be used for externalization of the events. So for example, not only packet events, but also topology events like link failure, device failures. So, and all, so to support this sort of mechanism in a controller like ONOS, there are two requirements. First of all, we should be able to extend the application easily to support different types of events. So not only packet events, but also other types of events. So another requirement is that the programmer should be able to use it for the external application with a minimum effort. Why? In the first attempt, we tried to extend the Kafka integration app that we have in ONOS to support the externalization of the packet processing. But the problem with Kafka is that whenever we want to use it outside of the STM controller, so we need to provide a basic set of classes to the programmers in different programming languages that they can use for creating and initializing of the consumers. In addition, we need to worry about the Kafka config parameters, Kafka broker parameters, producer parameters, consumer parameters, and also we need to tune all of those parameters to optimize the performance. So, and then we decided to use gRPC streaming. So specifically gRPC server-side streaming is one of the best options that we can use for distributing the event, especially if we use it with basal build system. The beauty of gRPC streaming with the basal build system is that we just need to compile a set of protobuf models in different programming languages, so it can be done easily with basal build system, as you know. So, and that's it. So we don't need to define a basic set of classes in different programming languages to provide to the programmers that they can use for using the application. So if we equip the controller, for example, ONOS in this case, to an event distribution system, so we will be able to implement most of the application, reactive-based or proactive-based application outside of the STM controller. And we also will be able to implement some of the services like topology service. So because if we can process, for example, LLDP packets or R packets outside of the STM controller, so we will be able to implement a topology service and construct a topology outside of the STM controller. So it means that this application is going to help in order to migrate from a monolithic architecture to a microservice architecture that each of the apps or services can be executed in a container outside of the STM control. So gRPC-based event distribution application will be executed as an app in ONOS. So it provides a gRPC interface to the external apps and services. So in the early version of the app, we provide two services. One service for the events. We call it an event notification service to distribute the events to the external apps and services. We also provide a service for returning incoming packets to the pipeline. So packet out messages. It means that the apps and services outside of the STM controller will be able to call that service to return the incoming packets to the pipeline. So let's take a look at a sequence diagram to give you an idea how the external apps and services will be able to communicate with the gRPC-based event distribution system. So it's a very simple protocol. Each of the apps and services outside of the controller, first they need to register themselves to the gRPC server. So they provide a client ID to the gRPC server, and the server is keeping the list of the clients that they want to use this service. Then they will each of the apps can subscribe to a specific type of events. For sure, an app can subscribe to multiple type of events, or multiple application or service can subscribe to a specific type of event. After that, the GRP server, which is running in the controller, start streaming events that can be packet event, device event, link events to the external app and service. In case an app or service needs to install flow rules, so in the current architecture, we can use REST API, but the perfect solution will be to extend this app or add a gRPC northbound interface to the ONOS in order to install flow rules using gRPC. But the current solution will be REST API. It means that we can use REST API to install flow rules, especially for designing the external reactive-based application. So, and all the apps and services also can return the incoming packets to the pipeline using the gRPC based event distribution system. So to implement this app in the ONOS, we need to define some new protobuf models. Some of them already defined in ONOS, so we can use them. But some new protobuf model needs to be defined, such as packet context, inbound packet, and their translators. So for the first version of this application, we need to implement two services. One service for externalization of the events, so we call it event notification service, and also a service is needed to return the incoming packets from the external apps and services to the pipeline. So later on, we can extend the app to support new services like flow service, if we would like to use gRPC to install flow rules on the network devices, or other services in case we need to define new service. So the app consists of two key components. One, a gRPC server that provides services to the external apps and services, and an implementation of each of the services that we define in the protobuf model. So we need to use packet processor and listeners in ONOS to implement those gRPC services. We can also use packet service to implement a packet out service. So these are the details, but there is nothing better than a demo to give you an idea about how this application can be used in practice for implementing of the external, for example, reactive-based applications or services. In the first demo, so I will show you an external reactive forwarding application, something very similar to what we have in ONOS now. The only difference is that the app will be executed outside of the controller in a Docker container. So, and then we also use REST API for installing flow rules and also retrieving topology information. So, as you know, it accepts incoming packets, compute the shortest path, and then install flow rules reactively using the REST API. So, again, we are using the REST API for this application, but it's not a perfect option. So finally, we will need to move to gRPC because REST API is really slow in installing of the flow rules. And at least based on our experimental results, we know that the externalization of the packet processing or event processing is not an overhead at all. So when compared with the flow rule installation, the amount of time that we need to install the flow rules is much higher than the amount of time that we need to serialize or de-serialize protobuf messages in the controller or in the client side. So let's take a look at the first demo. So in this demo, is it clear? Can you see it?
Yes.
Perfectly?
Again.
All right. Okay, good. So we have a terminal here on the top right side of the screen, which is the controller. So in the top left side of the screen, a reactive forwarding application will be executed. It will be a Docker. So I use Bazel as a build system in order to create a Java image, and then I will run it as a Docker. So we have two hosts, a factory network topology. So 10 switches have been connected together, and there are two hosts. To emulate web traffic, I'm using iPrep as a traffic generator in this example. So let's start the demo. So I ran the reactive forwarding application. So the application sends two messages to register and subscribe to the packet event. Then when we start sending traffic from this host to another host, the application receives the incoming packets. So it generates flow rules and install flow rules on the network devices, and you will see that. So the two end hosts will be able to communicate with each other. So the flow rules have been added using REST API. So I stopped sending traffic between two endpoints. So there is an idle timeout of 25 seconds. After 25 seconds, the flow rules will be gone. So if you start the iPref again to send traffic between the two end hosts, so you will see that again the packetting event, the packetting messages will be forwarded to the external apps, and then the external reactive forwarding application again compute the shortest path, install flow rules on the network devices, and then you will see that the end source will be able to communicate with each other.
That's nice.
All right. Okay. So this is the first demo. It's an external reactive forwarding application. For sure, we can implement a topology service outside of the SDN controller. Instead of using REST API to retrieve the topology information, we can use a gRPC between the microservices to retrieve topology information from an external topology service. So, but for the first demo, so we use REST API, which is practical. The second demo is a very simple demo to give you an idea how can we process other type of events. Suppose that we retrieve network topology using REST API. We construct a topology internally and see that how can we use this system in order to update the network topology whenever there is a failure, for example, in the links. So again, very similar to the previous demo, we have the controller running on the top right side of the screen, and then we have a link failure detector kind of application here. So whenever there is a failure in one of the links, by disabling and enabling the link, so the network topology will be updated, and you will see the number of links will be changed. The app is running. A registration and subscription request will be sent to the controller. So whenever there is a change in the network topology, we disable a link. So you will see that the number of links will be changed from the 30 links to 28 links. So it's a good application for monitoring of the events, link events, device events, this sort of things. To update the network topology accordingly, and we can use it in our application to react to the network topology changes dynamically. So here these two applications, two demos. Here are the references to the David Bainbridge presentation, OpenFloaty, and I would be happy to answer your questions if you have any. Thank you.
Well, thank you. This is great. This is actually along the lines of what one of the goals of the GRPC Brigade was a while back to demonstrate the suitability of the GRPCs by separating the reactive forwarding application. So you have, in effect, accomplished that here without taking on the entire, conversion of the GRPC interfaces. So this is really great. One quick question I have, and again, this is not at all a criticism, it's just a question. Kind of a complication of the clustered environment is that when you have
Thomas, I don't have your voice very well, so I cannot hear you very well. Would you please repeat your question again?
Yes, is this better?
Yeah, it's better now.
Okay,
Thanks.
I was speaking away from the microphone. So one of the complications with the distributed cluster was each node in a cluster generates its own set of events for its own internal application to deliver to its own internal components.
I see.
And so, like for example, this is one of the complications we hit with Kafka is how to consolidate the events. So when we externalize them, for example, before we put the events on the Kafka bus, how to make sure that only one copy of the event, which actually occurs on every instance of the controller, gets published on the bus. So in here, because this is not a Kafka bus, this is a little bit different. Here you're dealing with a gRPC stream, which is effectively a point-to-point construct, right? So that problem doesn't necessarily exist.
Yeah, because we don't need to worry about the queue management, the order of the events.
Right, but then some of the complication then would have to be if the point-to-point connection gets severed between the application and the specific ONOS node. There has to be some mechanism for reestablishing the connection to a different node in a cluster. Is that does it sound reasonable?
You mean that, for example, if an application subscribes to a type of event, for example, so and we would like to have similar applications to make it scalable, right? You mean?
Well, no, actually, well, so that's another aspect. But I had specifically the use case I had in mind is, let's say you have your reactive application, which let's say runs as a Python somewhere, and registers with an ONOS node, right? In this particular case, you had single node running, but let's say you have three nodes running. You have three nodes running.
Yeah, so
the one that
three instances of ONOS. You have three instances. Yeah, all right. Okay.
And the ONOS instance, let's say you connect it to ONOS instance A, and that ONOS instance dies. So the application then has to make sure that it detects the failure and finds another, basically, instance of that service somewhere else, let's say in either on node B or on node C, right?
Yeah,
so that would have to be an enhancement, I think, something like that to make sure that, at least in a context of current ONOS architecture, which is running kind of in a symmetric fashion, where the same functionality is available everywhere, then the connection has to be made to some other remaining nodes in the cluster. Is that?
Yeah, it's clear now, and that's an interesting problem. But at least for this version, so we are using one single instance ONOS, so we didn't think about these sort of problems yet. But these are the interesting things that to think of. So I don't have an answer for that question at this moment, but for sure we will think about it.
Yeah, and the reason I'm bringing it up is not necessarily for the context of your project, which you can certainly consider that. But if you give it any thought in the context of your project, I would really be interested in your findings or what you've learned from that, because we will have the same problem when we disaggregate ONOS. Now, when we work on the next generation ONOS, it will be different. If I ask you to bring back the picture, I think it was like on the third slide when you showed the monolithic versus disaggregated.
Yes, this one.
Yes. This is perfect actually, because this quite nicely lines up with our initial thoughts for next gen ONOS.
Yeah.
We don't necessarily. I wouldn't necessarily label the ONOS just the bottom part. At least in the next gen ONOS, it's going to involve all of the the pieces that are labeled ONOS, as well as the flow management telemetry and other things like that, but they're just going to be disaggregated.
Yeah, exactly.
But so to bring it back to my original question, we will still have to deal with issues of, let's say, having an SDN application which has a dedicated, let's say, GRP, stream or connection to a particular service. It will have to be capable of relocating that service should something happen to the instance of the service to which it currently talks to.
Yeah.
Because I suspect we will have to, you're absolutely correct on your kind of second slide, that the gRPC stream is the appropriate construct for dealing with these which are going to be fairly fine-grained and frequent events. REST API is not good, and using event buses like Kafka is not also that great, because at least not in my view, because it doesn't necessarily provide for the synchronous, not even the language and the toolkit tool chain aside for compiling serialization, deserialization in different languages, but even just for communication purposes alone, it's a fairly single-purpose hammer in my view, and we need something a little bit more nuanced, and gRPC certainly provides that.
Yeah, that's correct. So at least according to my experiment results, so I could say that REST API is really slow. Yeah, so 5 times slower than the processing of the packet. So there is a delay of 1 millisecond per switch to process that packet. So it is nothing. So, but it takes, for example, for switch, it takes, for example, to give you an idea, for example, 20 milliseconds to install flow rules using REST API. So the externalization of the packet processing is not the bottleneck, at least for this kind of application. So the flow rule installation is the bottleneck for sure.
Yep. But still, there's no point in inserting high latency remote procedure call mechanism. And REST API is definitely very, very heavy in that regard.
For the problem that you were stating, Tom, for the multi-node cluster, I think there is, two options, probably, at least in my mind. One is that the event distribution system knows the existence of an app, and that ONOS switches the point-to-point stream to another instance when it senses that the one that it had the stream in the first place died. So that's an option. Or the other way around, the app knows the existence of a 3-node ONOS, and if it senses the death of the point-to-point stream, goes and opens up a new one to another instance of ONOS.
Right.
I would go for the first one, because it's then the burden of the controller, ONOS, and not each app to have this mechanism. So it's probably up to us to come up with some sort of broker that establishes point-to-point streams depending on the existence or not of instances.
Yeah, so there are definitely, those are definitely two viable options. Each of them have its own caveats for sure. I was interested to hear. Go ahead, Adi.
Do you mean that somehow the ONOS should inform the external application whenever there is a failure in one of the instances, right?
I think what Andrea was suggesting, actually, that in presence of a failure, rather than even just notifying the application, it would be from ONOS side that the stream would be re-established from a different.
I see.
That was my take, at least, because the idea, and I've kind of done this in. I come from the Netcom side where it doesn't have multiple streams, and what we do is that we open one new session, SSH session, when the ONOS instance holding that session, the original session, dies. And I see this as the same. You have an external element that needs to collaborate with ONOS, and it has a stream to it. And when that session/stream is against an instance that dies, ONOS itself needs to take care of opening a new one. So the app would just receive a new request of stream and receive the events from a new stream from a different instance of ONOS that is still running.
So I disagree that the connection should be originated from ONOS back there, right? Today, the connections originated from the client, from the external client. And so
Yeah,
when
the request will be
right, so when that session dies, it's not ONOS's responsibility to reconnect to the client. It's the client's responsibility to reconnect to ONOS. Going the other way has some interesting problems. Let's say ONOS has 250 clients, or one client that keeps reconnecting, getting a new DHCP address, whatever, right? ONOS is not going to remember those 250 clients from history past.
Right.
We want ONOS to do as little management of those things as possible.
Yeah, I would agree with that.
So you really want the connections managed from the external client, I think, in this case. The other thing I think we need to think about, as original in the slide presentation early on, was part of the justification for this work, or the idea behind some of this work, is to allow applications to be portable. The more you, so we have to be careful here that any behavior between the communication between the client or the external application and the controller is possibly universal, right? So that same client might communicate to ONOS, might communicate to ODL, might communicate to Open Who's a What's It, right? And so you don't want to embed too much behavior specifically to ONOS in terms of how this communicates. Because you don't want to have the client say, oh, if I'm communicating to ONOS, I have to do it this way. If I'm communicating to Who's a What's It, I have to do it this way. You want to keep that model as simple as possible so that the most controllers might actually implement this. It's going to be an uphill battle to convince multiple controllers to even implement the same gRPC models, let alone implement more complex behaviors in the same way.
Right. Now, I would agree with that, David. Yeah.
But good stuff.
Yes. So while we're on this slide, I've actually already, I don't know if you know, during ONF Connect last December, we announced the intent to start working on the next gen ONOS. And
I just listened to your presentation.
Yeah, and so what I've started to put together a document which there's an overlap between the presentation and the document, to just start recording some of the tenets and kind of the general construction philosophy, so that we can start hashing these out in the open, not just with the TST, but also with kind of the leadership from the various parts of the ONOS community, service providers, as well as academia. And I actually do have, in response to the Register article where your advisor, Douglas Comer, was interviewed with respect to ONOS, and actually basically this subject, really. I have Larry sent out an introduction, and I'm hoping that we can meet with Doug when he comes to Bay Area sometimes in March.
Sure, I will let him know.
Yeah, so I would, in the meantime, what I'm going to do is I'm going to forward you the link to the document, and would be really interested in seeing your take as well.
Yeah, sure.
Okay, because this definitely falls squarely into that realm.
Okay, thanks.
So, no, thank you. This is really great. Thanks for taking time to do the presentation and to grapple with this topic.
Thanks again for giving me this opportunity to present our work in ONOS TST meeting.
No problem. Is there any other questions for Adib? Okay, if not, then I think we can, then again, thank you, Adib, and I think we can move towards kind of the second part, which is follow-on previous TST meeting with respect to how to proceed, and specifically how to populate the application, the external application list. And also kind of related to that, I would like to come to the closure of the Kubernetes applications for Jean. You assume, so let's deal with that one first, actually, if you don't mind. So I haven't had a chance to check mail comprehensively today, my inbox. How many votes were there for option number 1? Can you guys vote online? Is everybody online? Brian, are you online?
He appears not to be, Tom.
Okay, let me check whether we get a vote from him. So I voted for option number 2. I think, if I recall correctly, Jordan voted for option number 2.
Yep.
David, you voted for option number 1. Andrea, you voted for what?
Number 2, if we don't have a current example of number 1, and since that seems to be the case, I would go for number 2.
Yeah, but okay, fair enough. I'll be quiet, but that's okay.
We have to start somewhere. I understand that. That's
yeah.
No, I do. I completely understand that. I would be very open to using this as number as a first instance. Except Jean's message was fairly clear that he had reservations about doing that, and so I don't want to. Since especially Jean has been really great contributor, and I kind of don't want to punish him for this, right? Effectively. And so my tendency would be just to really just to, just let him put it in apps. I think we can leave the disaggregation exercise for next gen ONOS, at least the forced disaggregation, right? For next gen ONOS. That would be my tendency. So unless there are objections or I would just go with option number 2, which means that in this case it would allow Gen to host the Kubernetes suite in the ONOS main repo. So if there's no objections other than a regular vote, then Ray, can you maybe make that happen after the meeting? Thanks.
Sure.
Okay, and I'll send a message to Gen just in case he doesn't listen to this in time. Okay, and so second, let's talk about the specific follow-on for the application list. So if I recall correctly, the idea for the external repo was simply just to hold the inventory of the external applications. But it can also be potentially used to host the internal applications as well, right? So basically, this is like a registry for all apps that ONOS has. So we just need to figure out how to populate it, at least how to start populating with the internal ones. That would be my guess.
Yeah, I think that's the thing. We need to populate it first, show what we want from it.
Mm-hmm.
Give us an example to people of what needs to be there, and then let people contribute to it. That means setting a precedence and doing with the ONOS internal apps. And it's somewhat simpler for the ONOS internals app because we don't need to pre-package the OER and put the link there.
Mm-hmm.
It's just the ONOS code base and the OER already comes with ONOS, so you just need to activate it. So that's very similar.
Okay. Now, did you guys discuss? So clearly, this would be the repository for the raw data. Did you discuss any specific format for the data? Would it be XML or JSON or YAML?
We thought to use a formatted README file, the NMD file, plain and simple.
I see. Okay.
A text-based approach. But if anybody has better ideas, that's okay by me.
Okay, my thought was that if we maybe choose to use some sort of a structured format like YAML or JSON, we could write a very easy tool to basically just turn it into a README from there, and potentially also use it as a and then that way it would be machine readable, and we could potentially either augment the applications view in ONOS today, right? Because we have and and that way you could basically, the applications view in ONOS today could be used to extend the view to all the apps, and you could actually install and download the apps directly from within the ONOS UI, just as an example, for demonstration purposes. I don't think it would clearly be all that practical in for deployments and operations, because you'd be using programmatic ways to do this, but still it might be nice for show demo floors and kind of to show the concept.
Yeah, I like the idea.
And it might be something that would be, again, the value of this would easily translate to NG ONOS, because there we will have multiple repos from the get-go, and this could kind of be our sort of app store.
Absolutely, yeah. That's actually a great idea. And generating a page out of it, it's pretty good, I think. Yeah, and I think a YAML slash what we decide it to be, it can be easily through a tool can easily generate a README file or a wiki page like list.
Yeah, that was the thought. And that way we can maintain the individual application files individually, so they can be reviewed, merged easily, rather than having a single text document might also make for more conflicts during merges. There was also a thought. So any specific preferences? YAML, JSON?
Let's compose. So
YAML. All right, let's make it YAML. Ray's not so sure, but that's all right.
Yeah, it needs to die in a fire. But anyway, needs to what? Needs to die.
So
JJB flashback. Sorry.
oh, I see. All right, so let's make it YAML. Is there anybody who wants to? Well, I guess here, let me do this. I need some spare time to reflect a little bit. So I'll take a whack at it, basically by producing a kind of an automated fashion an inventory of the existing built-in apps. And this way also make sure that I'm in line exactly with what happened to the TST meeting that I missed. And then we can take it from there. Does it sound reasonable?
Yeah, I guess my question on the format would be whatever's easiest to build the tool, right? And for build query tools against the document. Because besides generating a web page, it might be interesting to be able to download the source document and then run queries. And I know there's like JQ and for JSON and YQ for YAML, just to pronounce specific parts of it. Yeah.
Yeah, and nice thing is with this, if you decide to change the format, well, then if it's in machine format, we can easily transliterate it from one to the other, right? It should goes in does not meet the bill.
And Tom, please feel free to ping me if there is any question you might have, because I hosted the last TST. So
right.
I sent out an email with the format, so if you dig for the email.
Yes, I remember seeing that. I just haven't had a chance to listen to the physical recording.
Okay.
I'll definitely will do that. Well, cool. Is there any other topics for today? So if not, then again, I just invite everybody to start taking at least the TST, if they can give me feedback or contribute to that next Gen ONOS thoughts list. Because what I would like to do is very, very shortly, I'd like to basically publicly make it publicly available in the spirit of doing all of this work in the open. But I just wanted to make sure at least we had some initial alignment of at least some of the chalk sketch. Okay. All right. If there is no other questions, comments, or subjects, I think we can close it for today. Thank you, everybody. And again, thank you, Adib, for a nice demo and presentation.
Thanks so much.
Bye-bye.
Thanks, everybody. Bye-bye.